Hi students, so we shall continue with the problems of relations and functions. In the previous class, we have completed exercise 2.3. So in this class, we shall continue with the miscellaneous unsolved problems. Clear? Already in the textbook or in the PDF which I have already sent to you, in that miscellaneous solved examples are given. So now I am going to solve miscellaneous exercise problems. Clear? So relations and functions, miscellaneous examples which are given in miscellaneous exercise. Okay. The first problem is the relation of the relation f is defined by f of x equals x square whenever x is in between 0 and 3, 3x whenever x is in between 3 and 10. Clear? Next, the relation g is defined by g of x whenever x is in between 0 and 2, it is x square, and if x is in between 2 and 10, your function is 3x. Clear? So from this f and g, we have to show that f is function and g is not function. F is function and g is not function. Okay. So now we shall continue with this problem. The relation f is defined as f of x equal to x square whenever x is in between 0 and 3. F of x is defined as 3x whenever x is in between 3 and 10. Okay. So that means now you have to say that this function is going to be the function. Sorry, this given f of x is function, and you have to prove that. Clear? Okay. For this, see here, we call 3 as the breakpoint. 3 as the breakpoint of this function f of x. 3 as breakpoint means this function is defined from, see there, 0 to 10. Clear? So this function is defined from 0 to 10. Here they are using 3 as the breakpoint. In between 0 to 3, your f of x is x square. In between 3 to 10, your f of x is 3x. At the breakpoint, your function is both x square and 3x. Both x square and 3x. So we have to identify our f of x at 3. Clear? Because x square is also calculated at 3. 3x is also calculated at 3. Okay. That means at x equal to 3, what is f of x? That means f of 3 equal to, see here, at equal function, your f of x is x square. Okay. So I will use 3 square and it will be equal to 9. Okay. So again I can use f of 3 for 3x also, because here also the function is lesser than or equal to. That means 3 is used for both x square as well as 3x. So that's why what happens, 3 into 3 will become 9. Clear? That means here 3 is the value of domain and 9 is value of codomain. So 3 maps to 9. 3 maps to 9 in unique way. In unique way. Clear? So this we are going to see in the next slide. Okay. So write down all this solution which I have written with sketch pen, and you can take the notes of this slide also, no problem. I am going to erase this. Okay. So now let us see the next slide, that what I have explained. Okay. See here. So this we have already seen, that is x is in between 0 to 3. Here you have to use 3. So this becomes 9, which we have already seen. And here also x is in between 3 and 10. So if I use 3 here, it will also equal to 9. That means 3 has a unique term. That means breakpoint has a unique value. Let us see in the next slide. Okay, see, here they have given very clearly that at x equal to 3, f of x 3 square is 9. F of x equal to 3 into 3, that's again a 9. At x equal to 3, f of x is 9. This is what we have solved in the previous slide with the sketch pen. Okay. So now from this what we understand, from the domain term, that is breakpoint 3 has a unique value, that is 9 in the codomain. This is domain. This is codomain. So breakpoint has a unique term, that is 9. Clear? So from this we can say that f of x is function. See here. Therefore from this we can say that from 0 to 10 the images of f of x are unique. That means we have to check only at the breakpoint. Don't worry about the other points, because it is from 0 to 10. 0 to 10 all the real numbers are included, but we have to check only at the breakpoint. So for that reason, no problem, we have to check only at the breakpoint. From that breakpoint we understand that all the terms of this f of x, that means x in between 0 to 10, has unique images in the codomain. Clear? So therefore this given relation is function. This given relation is function. So remember that this particular step is very important. I have solved with the sketch pen also, and it is present in the slide also. So you just take a note of this, and from this you can understand that all the elements in between 0 to 10 has a unique image. Thus the given relation is function. Okay students. So I will erase my all sketch pen words so that you can get a clear picture. Okay. So see here. Again I will explain this. That means the relation f defined by f of x as x square in between 0 to 3, 3x in between 3 to 10. That means it is defined from 0 to 10 and the breakpoint is 3. So at 3 you have to check f of x. Clear? So put x equal to 3. See here, at x equal to 3, this gives you 9. At x equal to 3, 3x also gives you 9. That means the domain value of 3 has a unique image 9. Okay. Therefore, x in between 0 to 10, the images of f of x are unique. Thus, the given relation is function. Okay, students. So, from this, you can understand that f of x is function. Now, let us see g of x. Okay. The relation g, the relation g is defined as g of x equal to x square whenever x is in between 0 to 2. G of x is defined as 3x whenever x is in between 2 to 10. Okay. So here you can observe that, or you can see that breakpoint is this is from 0 to 10 and the breakpoint is 2. So you have to check at the point 2. At the point 2, what this function gives. If it gives unique term, then it is a function. If it doesn't use unique term, it is not a function. Clear? Okay. If I put x equal to 2, what happens? See here. If I put x equal to 2, x square, that means it is between 0 to 2. So x square will give you 2 square. So it will be 4. Therefore, g of x, again at x equal to 2, you have to choose 3x for the second time. So it will be how much? 3 into 2 will be 6. That means two have two different images. One is 4, another one is 6. So 2 maps to 4, 2 maps to 6. Therefore, 2 is not having 2 is not having unique image. 2 is not having unique image. Therefore, it is not function. Therefore, it is not function. Clear? So that's what we are going to see in the next slide. See here. Hence, element 2 element 2 of the domain of the relation G corresponds to two different images, that is 4 and 6. That means 2 has two different images, one is 4, another one is 6. Hence this relation is not function. Clear? Hence this relation is not function because of this 2, it has two different images, one is 4, another one is 6. It gives that it is not unique. It is not unique. So from this we understand that g of x is not function. Clear, students? Therefore, from the previous slide we have shown that f of x is function, and in the next slide we have seen that g of x is not function. Just you remember 2 points. See, I will write here the important points to solve this. The important points to solve this is verifying at breakpoint. Verifying at breakpoint. What is this breakpoint? In the f of x, in the f of x, you can see, in the f of x, you can see 3 is the breakpoint. In the g of x, 2 is the breakpoint. You put 3 in the f of x and check output is unique or not. In the g of x, you put 2 and check it is unique or not. Here output will be 9. Here output will be 4 and 6. So because of these two outputs, g of x is not function. Because of this single output, f of x is function. Clear, students? So I think this question is very much clear for you all. So I go for the next question. So before going to the next question, you can pause the video and you can take the notes. Clear? Okay.